All right, welcome to day 3 of Next. The number 3 is really important today because you'll see a lot of threes in our session here. So it reminds me of an old joke or old saying. There are 3 kinds of people, one who can count and one who cannot. So it takes a little time to hit you, but we'll get your gray matter going for this talk. So I was talking to some of you around before the start of this talk, and it seems like there's 3 types of us here in the room. One who had a late night yesterday and had a great time at the concert. Please raise your hand if you're one of those. All right, awesome. Thank you for making the effort to get off your beds and getting here and filling the room. Then there's the second kind who were disciplined and just went to bed on time or about time. If you're one of them, raise your hands. All right, thank you for your discipline and being here. And then there's the third kind who are not sure if they slept or when they slept. If you are that kind, if you are that brave heart, please raise your hand. Oh, there's 2 or 3. I see 4 or 5. Thank you. Thank you for whatever you did to get here. We really appreciate it. So welcome to the first session of the last day at Next, AI in Financial Services. My name is Aakash Bordia. I'm on the customer engineering team with Google Cloud. If you're a prospect or a new customer or an existing customer of ours, you're likely working with someone on my team or a partner of ours. So our session here is a story session, which means we have 2 customers and a partner that will come up here in approximately 15-minute sections and share their journey to cloud AI, which means they'll talk about their problems, their use cases, and their solutions. So in these 3 stories, you'll hear our partners and customers talk about how they're leveraging the cloud AI stack, be it the platform, which covers our development environment and our robust infrastructure, or be it building blocks, which could be our predefined models or the AutoML models that you can train. Or we could also talk about services and solutions, which is very important from a strategy and culture perspective at a financial institution. So this should excite all you builders and all you leaders in the audience, because we're going to go top down the stack. Since we are likely going to be running out of time towards the end, I encourage you all to use the Dory through your mobile phone and post your questions. If we have time towards the end, we'll do live Q&A in the room. Otherwise, the group of speakers will huddle outside the room, and you can come and ask us questions and discuss. Awesome. Having said that, let's dive right into it. We'll start with some fantastic motivation by David Furlong from the National Bank of Canada on how to set up your AI program. So this is a more business track of this session, where Dave talks about how do you influence culture to execute on a successful AI program in a large organization such as yours. We'll also take it a notch deeper with Daan Gönning of RaboBank and Lee Boonstra, who's my colleague on the customer engineering team, who come up and talk about customer excellence using our machine learning APIs. And finally, Jonathan Jeng and Dhruva Reddy from our premier partner, Pluto7, will come up and talk about how they have worked with our PSO, professional services team, to work on solving some of the tough risk management problem that financial institutions face. So let's start at the very top of this stack. In fact, it's a level higher than shown here because it encompasses the whole stack. Very important to a successful cloud AI program is your strategy and the culture in your organization. They are both very critical to setting up a successful AI program and execution in your organization. And so to talk about this, I would want to welcome Dave Furlong, SVP for AI and Innovation at National Bank of Canada, up on the stage. Dave?
When I was younger, I could jump, but that's behind me now, I think. Yeah, I could try it. I've been asked to add a few things to the presentation this morning to give you some context, a little bit of context about National Bank. There's 6 large banks in Canada. We are one of them. We're 160 years old. We manage about 500 billion in assets and have about 300 billion on the book. We've been involved in AI in some capacity for quite a while. Now, we didn't know it when we were doing it, but we were. We started deploying particle filters in 2007 to replicate hedge fund performance, and then we moved on into algo trading. That was strict algos, and then we actually started to apply AI to the algos to improve them, all with supervised learning and supervision by a human. So we've been at this game for a long time, but that's the capital markets arm of the business. I won't talk about that. I'll talk to you guys about what we're doing in retail and commercial, which tends to be a slower pace organization in any bank than the capital markets side. And it presents different challenges. And you'll see when my colleagues come up, they'll talk a bit about some of the challenges they've faced, and it's not just technical. So, here we go. All right. So, what does it take to bring a 160-year-old company into AI? How many people in the room work for an old line company, a company that's older than 20 years? Perfect. I have friends. So I'll talk a little bit about our strategy and how we go after things. But the really important part about what we're going to talk about is the lessons learned, or as I call it, 2 years of self-introspection or self-discovery. So, from a strategy perspective, it's pretty straightforward. I can characterize it very simply. 1, we want to improve revenue opportunities for us, for our company. 2, we want to make our experience for our clients and for our staff better, because that leads to retention on both cases, really good in our organizations. And 3rd, we want to increase our operational efficiency or remove costs from the ecosystem. So for the next 6 months, here's our top tier priorities in the retail commercial side. 1, build out a production ecosystem. We already have a smaller production ecosystem. What we need is something that is infinitely scalable and infinitely expandable, allows us to use open source, allows us to use platform as a service where appropriate, and to deploy containerized solutions. Second thing we need to do is enhance our decision models. If you think about banking this way, you make a decision to market to someone, then you check for fraud, then you underwrite them, then you manage them over a life cycle, and God forbid they go into collections, but you manage that as well. So those decision models can be adjusted and synchronized using AI, leading to a much better outcome. The next one we want to undertake is in operations, to apply AI, natural language processing, intelligent routing, to how we manage all documentation and customer interaction from a servicing perspective. And the final one, and this is really important, sometimes chatbots or dialogue engines are referred to pejoratively. I can promise you they're not, because what happens is in an organization where your frontline staff has turnover, you need to codify the knowledge and put it in front of them and the client, because you're empowering both your staff and the client. So the better your dialogue ecosystem is, the better the experience is for both. So, lessons learned, or as I call it, David's mistakes. Two years ago, we had put in place an AI team, and it treated it as if it were advanced analytics. How many people in the room have an advanced analytics capability and are just building AI now? Okay, so don't do what I did. And what I did was I went out and hired a bunch of AI scientists, put them together and said, now AI stuff. That is not how it works. Right? In advanced analytics ecosystem, what happens is someone comes in with a business request, they model it, and then they hand the output of the model to somebody else who creates business rules or procedure, et cetera. AI embodies all of that. So as a result of that initial decision, of course, what we didn't do is we didn't fund end-to-end software development. AI is software. It is what it is. We also then, as a consequence of that, didn't hire data engineers, software engineers, people who are familiar with the AI stack. And of course, then the other thing we did was we continued to focus on building data repositories. So we kept building data warehouses instead of focusing on data in flow or data in stream. Because if you really want to be effective in the next generation of banking, you have to catch the stream and change the stream with AI. And then finally, because of all of those things, we anticipated at first that our technology stack could be internal. Turns out that that wasn't efficient either, because we need infinite scalability up and down as required. We need open source. We need different security models and security paradigms than we've used historically. So about 12 months ago, we stepped back and reconfigured things, and it worked pretty well. So what we did from an operating model perspective is we took a business owner with a business problem. Gave them an AI scientist, gave them a software engineer, data engineer, verification engineer, and said, solve a business problem. So they started going end to end, because for those of you who've worked near telecom, telecom has always had what's called a last mile problem. So does AI. The second thing we did was we started to fund end-to-end software build. So we changed our funding model. And of course, with that, you need to change your talent profiles. So you need to hire cloud engineers, full stack developers, software engineers who are familiar with AI, people who know how to do monitoring of live AI models, because they change. And then data, we began the process of changing so we could intercept data flows. I mean, I have a very good colleague here in the room who runs our fraud ecosystem, and he'll look at me often and say, David, if I catch the fraud after the money's already left, catch it in stream, deny the transaction. And then finally, if you want to do that, I'll go back to, you need an open, scalable, robust infrastructure. And one of the things that we found with Google as a partner is they can provide it all. So we use GKE to containerize solutions for us and put them out there so we can buy a third-party specialized solution, deploy it. Or we use GCP for, platform as a service type behaviors, AutoML, et cetera. And the breadth of the solution set is what's allowing us to attain velocity, scalability, as we need it. So with that, I'll conclude, because there's a couple of things I want to leave you with. One, AI can absolutely help you accelerate your objectives. No ands, ifs, or buts. But you do need to change the way you work. Like, I went down this path, and hopefully if anybody comes out of here today understanding the mistakes I made so you don't make them, it's time well spent. And then finally, if you're going to go after this, change management is critical. Because if you change something that affects staff, clients, et cetera, you need to manage all of the change around that. Do not underestimate its importance. There's critical items. And with that, I'll conclude and give time to my colleagues who are going to get up and talk to you about practical examples of everything I just spoke about. And so let me turn it back over to Aakash.
Thanks, Dave. That was motivational, inspirational on how to go about, setting up a cloud AI program in the real world, in a real financial organization such as yours. So now, let's take it a notch deeper. Now let's talk about, how could the builders in the house use some building blocks from our AI stack to build some customer engagement, improvements using technologies such as Dialogflow. And to do that, I would like to invite Daan Gönning from RaboBank on the stage. Please welcome Daan.
Thanks. Thanks. Hey all, thanks for having me on stage today. It's really awesome to be here and to showcase our Google Assistant project. First of all, let's see how this works. Almost. How does it work? Does it work? Yeah. Oh. Thanks. Little green one. Cool. First of all, my name is Daan Gönning. I am a freelancer and currently on an assignment at RaboBank, where I am leading a program about digital interaction. For over 1 year now, we are working together with Google to build our Google Assistant Action, or as we call it, the Rabo Assistant. Basically, what we want to do is banking with your voice, make that just as simple and just as easy as banking with one of our mobile applications. But why? RaboBank is doing this. Let me rephrase. In the Netherlands, RaboBank is a pretty traditional bank. Definitely no first mover, but still we developed a Google Assistant Action, and still we are the only bank in the world that has connected client accounts, such as balance and transaction information, to the Google Assistant environment. And we do this for one simple reason, because our customer is changing. A couple of years ago, banking was pretty simple. We managed the whole flow of data. We had a Rabo customer, which has a Rabo bank account, banks in a Rabo mobile banking app, and when in trouble, he reaches out to the Rabo service desk. Like I mentioned, we all had the whole flow of data. We call this the happy flow of data. You have a great service or a good product, which attracts customers. Those customers generate data, and with the data, you improve your product. And that goes on and on and on. But now, our customer does a lot of interactions with third parties. People are tired of using mobile apps. And with open banking coming in, there are a lot of combinations of new services and new channels. People are switching more and more to third-party conversational channels, like WhatsApp for Business, Google Assistant, Facebook Messenger. And that means the happy flow of data, as you see it here, is being disturbed. We don't have all the data anymore. We don't have the full control. And that is the reason RaboBank is in this conversational domain. We want to learn what it means to be on a third-party channel. We want to learn if our customer likes banking with voice. And how do we make sure, when we have no freedom in design, and no freedom in user experience, how do we make sure our customer sees the Rabo Google Assistant action as the official one, for example? All kinds of questions we are doing in this program, all to validate and just to experiment with new technology. And that in combination with the graph behind me, it says it all. We need to be present on the voice domain, just to test. It could be the next big thing. And when it's not, I doubt it, but when it's not, we just learned a lot. That's for sure. So that's the why, but then the how, and that one is pretty easy to say, but fairly complex, because we are a bank with a lot of processes, a lot of rules, a lot of everything, just a bank. And a couple of those lessons I want to share with you today. And the first is focus. When we started working together with Google 1 year ago, we created a mission statement, I get to buy. The Google Assistant action, with that action we wanted to get the digital savvy users. Those users must see RaboBank as an innovative bank. And we want to provide that, we want to accomplish that by proactively serving signals about the finances that feel seamless and magical. Without this kind of focus, you will be lost, especially in a corporate, but really within a bank. So get your focus, get your focus straight. Another lesson is in the team structure. We decided to build speedboats, a kind of guerrilla teams. Teams who can test the water, move fast, break things, be flexible. No RaboBank legacy, no double backlogs, just team focus, only on one thing. Each case in my digital interaction program is such a speedboat. And when successful, we pull them back into the big oil tanker called RaboBank. When not successful or not validated, the speedboat sinks and people are going back to the normal work, life, or other speedboats. Really short before the demo, one of the parts is the execution. When we started this speedboat, we had some traditional roles. Think about a product owner, a developer, some other stuff. But after a while, we kept adding roles, and we ended up with this bunch of people for one Google Assistant action. But when you look closer at those roles, you still see the more traditional ones, like a product owner, like a developer. But you also see data science, marketing, and some special ones, like conversation design, compliance, legal, and risk, and a chief pushing officer. For example, we added conversation design, because writing for voice really is different when you compare it to writing a website text, for example, or even when you write a conversation for your text chatbot. Voice is a whole new way of writing your conversation, so it needed some special attention. And of course, compliance, legal, and risk. Again, we are a bank. And to be honest, it was the most painful part. It really was a pain to get approved internally. Discussions, do we want to be on a third-party channel? What is Google doing with our data? All kinds of discussions in the whole bank, from to the top. Basically, really to the top. It was terrible. But once again, Google helped us. Google said, no, we are not doing anything with your data. You are in the enterprise agreement. It's all safe. And that is the part the latest role came in, the chief pushing officer. This is a kind of sponsor, and it's the latest advice I want to give to you. When you do such an innovation, get a sponsor internally. So in the top of your organization who said, okay, I believe in this project, I believe in what you are validating, so I will support you. So when we are stuck with compliance, legal, and risk, the chief pushing officer said, okay, now it's clear, Google said how it's done, so move on. We push it, we are doing this. I think without a chief pushing officer, we're still not live at the moment. So it was a really crucial role, a critical role inside this project. I have some minute left for a demo, so I will showcase it live without demo effects, I hope. Let's switch the screen. Ah, there it is. Cool. Talk to RaboBank.
All right.
Cool. What's my balance?
Your current balance is €2,177.97. How can I help you?
I want to set a budget.
The Rabo Assistant can help you setting up a budget. I can then tell you how much you spent and send you notifications when reaching certain limits. Do you want to set up a budget?
Yes.
First determine the amount and then the period. What should your budget be?
€200.
Okay, until which date is this budget?
Next Friday.
Do you want to receive notifications to inform you about your budget status?
Yes.
Okay, thank you. I will notify you when you reach €100, €160 and €200. You can always ask for a budget update. See you next time. How can I help you?
Cool. Thank you. Lee, please join me for the Dialogflow demo.
Thank you, Daan. So hi, everybody. My name is Lee Boonstra, and I work as a customer engineer for Google. I'm mostly working with the banks and insurance companies in the Netherlands. And chatbots, that's like a topic that I get very excited about, but it's also a topic that a lot of companies are asking me questions about. I think nowadays, we shifted, like in the past where companies were building a lot of mobile apps. Nowadays, the companies are more spending their time on building chatbots. And one of those reasons why they're doing that is because you can trim a lot of business costs by working on chatbots. Like what you see here in this research from Juniper, you can trim over 8 billion. And that's a crazy amount of money, right? And now you probably are asking, wow, how can we do this? Well, let's first take a step back and look at chatbots. What is a chatbot? I typically would say there are 3 types of chatbots. You have seen the example of RaboBank, the voice assistant, the Google Assistant or a Google Home or a Google Hub. Those are typically the voice-activated speakers. And we have them also. You have that also on Alexa or on Apple. That's the voice-activated speaker. The other example that's more like the regular chatbots that you know, like for example on a website. Often people see that as an iframe, but you also have them in social media. And then the last example, that's more like the call bots. These are integrated in your IVR system or in your phone line. Not often people think about this, but this is a very effective way in how you can trim business costs. And I will explain a little bit more about that today. I will go through a couple of architectures to show you this is how you could implement something like that. So if we first look into the Google Assistant, Typically, your users, they talk to the Google Assistant or on the Google Home. And the Google Assistant is connected to Dialogflow. Now, Dialogflow, that is the tool that does intent matching. So basically, you create in Dialogflow, it's a conversational tool. You create your conversations. You have your content people, your UX designers, writing conversations in this tool. And the intent matching is based on natural language understanding, so machine learning, AI. We understand what has been said. So it doesn't matter if your users are saying it a different way or if they spell their questions wrong. We can match their question to a scripted answer in the system, or that can be an answer through an API. But we do this intent matching. So that's Dialogflow. And Dialogflow, that has automatic integration with the Google Assistant. So then you start your whole conversation on a voice-activated speaker like that. Now, for a website, it's typically like your users, they write on the website in the chatbot. And again, you can use Dialogflow to do the intent matching. Now it's not voice, but now it's just text. Works the same. You can enhance it a little. I see this a lot that companies are doing. Then they, as soon as the chat escalates, we can detect that, for example, based on sentiment, or we can detect that based on fallback scenarios of a chatbot. Then we switch over to a human, and that person takes over the chat. He sees the whole transcription, and continues the conversation that way. But how about a contact center? I mean, like the most people probably have like a traditional contact center like this, where you as a user, your customers, they call to your phone number, and the next thing that happens is you're put on hold. You're in a waiting line. And it takes a while. You hear like a tape and like a recording, and then it starts playing. It tells you like, oh, press 1 for X, press 2 for B, and if you're very unlucky, you have to wait all the way till number 9, then you press 9. Again, you have to wait. Then somebody picks up the phone. You phrase your questions. That person doesn't know how to answer you, so she forwards you again. You have to again rephrase your whole question, and then hopefully you get the right answer. What we see a lot at the insurance companies at the end of the year, when they're like everybody's changing their insurance policies, then it's like hot within the contact center. So what these companies are doing is they're hiring lots of students to pick up the phones. And they're obviously not as much trained as people that are normally in a contact center. So that way, the quality of the call is also not always great. So this experience is very painful, and it doesn't need to be that way, because you can create a modern contact center as well. And it is exactly with the same tools as what I'm explaining first, as for the website or for the Google Assistant. It's through Dialogflow. And within Google, we have Contact Center AI, which can do this within your IVR system with more components. Or you can build it yourself with Dialogflow, because the idea is, like, you call, and at that moment, you're not put in a waiting line. No, the chatbot picks up the phone. It answers you, or how can I help you? You ask your question. Either the bot knows the answer, so you hear like a computer voice back, like a WaveNet model, so text-to-speech, that tells you the question. Like, for example, like in an insurance company, there are always like a lot of questions that are always very common. So let the bot just answer that question. And if it's like a more difficult question that the bot doesn't know, then we can route it to the call center agent, so the human. But we can help that call center agent by showing the suggestions on the screen, by showing the full transcription of that the person had first with the chatbot. And while they're talking, while the person is talking to the human, you see like live suggestions on the screen. So no longer you're put on hold, and you always can guarantee that you give the same quality because, the person just reads up the screen. So these are like very great ways. Wouldn't it be nice if you just built one AI solution, one solution that can answer all these questions anywhere, and that is available from everywhere, right? Because what you don't want is build all these separate solutions one by one. I mean, like, you should stop thinking Google Assistant as a destination or a website chat as a destination. You start seeing it as a channel. So that way it means like the Google Assistant, that is a channel, Alexa is a channel, social media, Facebook Messenger, that's a channel. Your website chat, that's a channel. And also your contact center, your IVR system, that's a channel. And it's powered by Dialogflow, like where we do the intent matching, understanding what's been said. And then it's based on this AI platform that you created to route it to the right channel that gives you the answer. So either the answer will be on the Google Assistant, or it will be over phone by the live agent that reads out the suggestions, or as text in a website. And then the very nice advantage of this all is then once you're building this AI platform solution anyway, and you can also power it by analytics. So you can really see like what are the questions that people are asking, what is my customer thinking about my brand, and how can I improve it over time? So you continue this cycle. But even if you just add one new AI channel, I think you can already improve your customer experience and trim a lot of business costs. So with that, I would like to thank you. So next, I'm going to hand over to Jonathan and Dhruva from Pluto7, and they can talk about the cloud AI platform. Thank you.
Thank you so much, Lee. So I'm Dhruva Reddy Tiruvuru, Pluto7, cloud data engineer at Pluto7. We are a Google Cloud Premier partner, and we are one of the key partners for artificial intelligence and machine learning implementation across the verticals, such as high-tech, manufacturing, and retail and healthcare. We serve the global market. We are based out of Bay Area, Los Angeles, and India. Talking about the use case, today, some of the financial institutions are facing problems to view the scalable predictive view of the loan delinquency and then likelihood of the customers being default. And then being part of the Google Cloud's professional services organization, we built an accelerated solution which demonstrated how we leverage the capabilities of machine learning model to predict the loan delinquency status of a customer. Briefly talking about the data set, we used a loan level credit information performance of a customer that Freddie Mac has made it publicly available. This data set had around 26.6 million records originated between the years 1999 to 2017. So that means it was pretty big. Some of the specific credit performance information in the data set includes voluntary repayments and then loans that were foreclosure alternatives, and few other information such as the expenses, net sales, proceeds, and mortgage insurance repayments. And then this is the high-level architecture of the solution that we have built. The loan-level data set of the credit performance information about the customers, which is made publicly available by the Freddie Mac, is stored into the Google Cloud Storage. Google Cloud Storage is an online RESTful file storage system, which is used for storing and accessing your data on Google Cloud Platform's infrastructure. Followed by that, we did our initial data exploration and analysis using BigQuery. With simple SQL queries, we were able to scan through millions of records within seconds. And then followed by that, we use data prep and data flow. Data prep is an intelligent data service tool which helps you to visually cleanse, transform, and explore your data. And it also helps us to wrangle the data and prepare the data for machine learning. Followed by that, we use Data Lab. Data Lab is built on a Jupyter Notebook environment that helps to bring it's equivalent to Jupyter Notebook. And the cloud source repositories, which is used to push our code and do the code versioning. And followed by that, coming to the most important part of the high-level architecture, which is Google Cloud Machine Learning Engine. That is where we hosted our different approaches and different machine learning models we tried out, which got deployed and then made predictions out of the ML engine. And Cloud Functions, I'll briefly explain what it does. Cloud Functions, it helps us to connect the different services. It gets triggered whenever an event occurs that it's listening to. My colleague will explain or talk about that more in the later part of the session. Here. Data preparation. So data preparation is very critical in the journey of machine learning. So over here, after initial data exploration and analysis, we figured out that some of the features had very skewed data. Like, for example, delinquency types. Some of the values occurred more often, whereas others were very rare. So this will degrade the ability of our model to train if we feed this raw data as such. So in order to get over this, we followed a strategy called binning, which helps us to convert the continuous numeric values into discrete categories. And over here, each bin represents the degree of intensity of each class. Over here, as you can see, the class 0 represents it's safe, and the class 1 is moderately safe. Second is moderately risky, and third one is risky. We use this as a label for prediction. Followed by that, we also did a feature engineering. We had the raw data had almost 40 features, but we did feature engineering by creating an aggregated column such as min, max, standard deviation, average, and so on of each and every column. And then followed by, we feature engineered a column which finds out the frequency of each bin that we have created, and likewise recency as well, how recent each and every class occurred. And then the final data set we used to, on different machine learning approaches that we tried, like vendor estimators, TensorFlow estimators, XGBoost, and we were fortunate enough to try AutoML when it was in pre-alpha stage, since we were part of Google Cloud Professional Services Organization. All right, this is not letting me view my own video. So I'll quickly explain whatever the feature engineering that we have done, it's on top of data prep. Data prep is, helps us to visually cleanse and wrangle the data and also perform feature engineering. And all the series of steps are stored in form of a recipe. And once we run the recipe, under the hood, what it does is it fires up a data flow job. Data flow job is an ETL tool. It builds an Apache pipeline for you. You don't have to code it, and it's fully managed. By fully managed, I mean that you have to focus on your data and analysis, and you don't have to worry about the underlying infrastructure. Google will handle it for you. On your right, as you can see, you can see the number of current workers at this present, and then number of target workers, and how Google Cloud Platform will scale according to the load. And this graphical user interface will help you to see the status of the job, whether it has completed or it's still under progress. Once the data is once the flow is completed, the target results will be stored in the Google Cloud Storage bucket. And my colleague, Jonathan, he will talk about the rest of our machine learning journey.
Cool. All right, so as Dhruva mentioned, we use Google Cloud Functions. we set up a function called CMLEPred, you see over there. It's triggered by an object.finalize event in the bucket specified there. So we created one called loan delinquency input for N19, X19. So this cloud function, what it'll do is it will take the data, put it in the bucket from data prep, and then it will send the process data to ML engine, cloud machine learning engine, to form predictions. And it will take those results and send them to a CSV file, two different CSV files. One for containing, about this current, the current predictions, and one to compare it to the previous models. And it will put those files in Google Cloud Storage. And so it will take those two things. It will send them, we set it up to send it by email because you could actually send it to your own company's communication system. We did not do that. We just sent it by email. So the important thing to note here is that it is almost in real time. So we were getting it via online predictions because we're interested in speed. But if you are not concerned about the rapidity of that, you can request a batch prediction. So you can submit a batch prediction job. So one email shows you how the model performs. Over here, we use a metric called mean per class accuracy. And the lower email shows an interpretation of the predictions. So you see there's a loan sequence number label, and then it shows you the prediction interpretation for that loan sequence number. Okay. And also, as I mentioned previously, the data file is stored on GCS, Google Cloud Storage. And using that, you can set it up to form a dashboard via Google Data Studio or Looker or Tableau. So over here, we used Google's Data Studio. On the left, we can see certain information about the data that may be of interest to you, such as how the values, how the class is distributed. And then in the middle, we have visualizations of the machine learning, the current machine learning model. So on the top, we have a confusion matrix regarding the predictions that were just made. On the bottom, we have it compared to other models that we use. So over here, you see a couple of TensorFlow models, so DNN linear combined classifier, and then we also use several vendor estimators, as well as XGBoost. And on the right, you may notice that it's blank. You can choose to implement different actions based on the predictions that you made in the previous two columns. And over on the right, you can have it show you just the results of those actions or recommendations for what actions you may choose to produce. And on the top, you see a live refresh button. So as I said, the data gets dumped into GCS, cloud storage. And then you can hit that refresh button to give you a dashboard with the most up-to-date data. So here, we'll be talking a bit about interpretability. So there are two prominent approaches to interpreting machine learning models. So on the one hand, you have intrinsic simplicity. So you may choose to form a more intrinsically simple model, such as a sparse linear model, or decision trees. On the other hand, you have it's compatible with more complex models such as neural networks, so what are typically considered black box models. And over there, you may want to, it's called post hoc, and you may want to form global explanations of the model itself. And over there, we have the most famous approaches would be feature importances and black box beta. So black box estimation through approximation. Oh, sorry. And then we also have, you might want to examine locally interpretations. So you might want to look at each individual prediction. Over there, you can use something called SHAP, or just to examine the individual predictions, what led to that prediction, which features and which values were important, like which helped you determine that class, that prediction. So over here, we're going to show the SHAP values. So SHAP actually refers to a solution from the cooperative game theory domain. So what it does is it takes, you can construe a game as a scenario, the game players as the features, and the payouts as the contributions. So how much, we use an XGBoost ensemble estimator, and for the criterion, we chose Genie. So we wanted to see how much each feature helped lower the Genie contribution. And you'll notice on the x-axis it says the mean SHAP value for that feature. So what it does is it finds the mean. You see the XGBoost model is an ensemble of many trees, and it wants to take the mean SHAP value observed across the entire ensemble. So that gives you a high-level overview of the model. And you may be interested in, before the evaluation, before the prediction, you may be interested in the entire, if I'm going to get this class for loan delinquency prediction, which features are more important? What should I prioritize? And this will give you an overview of that. However, once the evaluation has been made, you may wish to examine in more detail your individual case. So over here, we use some module called ELI5, explain like I'm 5. So what it does is it will take the different amounts that it lowers the Gini coefficient. In your case, you may choose to use a different criterion, such as entropy, but we chose Gini. And over here, what you will see is how much each, the contribution of each feature for each case. So over here, we're showing 2 different individuals of class 1s, which, as Dhruva showed, we determined to be moderately risky. So class 1, 2, 3, they're low delinquency range. They're not perfectly safe, but they're not too risky either. But you see 2 different classes, 2 different individuals. They receive different feature importances, like different features were determined to contribute to each prediction. And we chose to include only 4 features because humans tend to prefer more brief, concise explanations, whereas so we only chose to include 4, and you will see X more positive or X more negative and those will tell you the different features. You can increase it or decrease it as you prefer. And I don't want to bore you about this contribution or this interpretation, so we'll just move on. And yeah, so this is the end of what I want to say. I will open up the floor to any questions that you may have for my co-speakers and I.
Thank you, Jonathan. Thank you, Pluto7 team. So we can go on for a couple questions since we are out of time. The first one is an easy one. Will this slide deck be available online? So we are checking for you. I did post on the Dory. The video should be available on YouTube. The second question is for Pluto7. So if you guys want to come up on the stage, the question is, how did performance of the AutoML estimators compare to the TensorFlow and XGBoost estimators? So again, how did the performance of AutoML estimators compare to TensorFlow and XGBoost?
Right. So as I showed previously in the dashboard, there are some model evaluation metrics for the different models that we use here. So we have mean per class accuracy, precision, recall, and F1 score. And we found the best one was actually XGBoost for our case. It outperformed TensorFlow. We used a deep and wide model, and it outperformed vendor solutions and AutoML.
All right. Thank you, Jonathan. Thank you, everyone, for attending. Have a great rest of the day. And if you have any questions for the speakers, we'll be huddling outside. So thank you.